Okay, so now let us look into this problem, which is to generate all the permutations of a given string. So let us start with few of the examples. So for the empty string as input, the output will be the empty string, because the only permutation of the empty string is that empty string itself. Similarly, for this string with single character x as the input, the output will be again that string with single character x, because that is the only permutation of the given input string. Now for the input string xy, the output will be the set of strings xy and yx. So these two strings are the permutations of the given input string xy. Now for the input string abc, the output will be abc, bac, acb, bca, cab and cba. So all these 6 strings are the permutations of the given input string abc. Okay, so now we are clear with the problem. We are given an input string and we want to output all the permutations of that given input string. So now let us try to identify whether it's a recursion problem or not, which is our first step. So for that, what we do is we assume that we have solutions for the problem of size n-1 and we use them to generate the solution for the problem of size n. So here in this case, let us assume that we want to generate all the permutations of the string abc, and we are given all the permutations of the string bc, AB and AC. So here ABC is the string of size n, which is n equals to 3, and we are given all the permutations of the string of size n-1 or 2, which is BC, AB and AC. So now our question is whether we can generate all the permutations of ABC using the permutations of BC, AB and AC. So let us see how we can do it. So let us start with BC. So here in BC, the missing character as compared to the string ABC is A. So we'll pick up that missing character A, and what we'll do is we'll append that missing character as the prefix for all the permutations of BC. So what we'll get is, if we append A here, then what we'll get is ABC, and similarly if we append A here as a prefix, then what we'll get is ACB. So we'll place that ABC and ACB in this set here. Similarly, we'll do that same thing for the string AB. So here in the string AB, the missing character as compared to the string ABC is C. So we'll pick up that missing character C and we'll place that missing character C as the prefix for all the permutations of AB. So here, if we place that character C as the prefix for all the permutations of AB, we'll get CBA and CAB. So we'll place them here, CBA and CAB. And similarly for the string AC, so the missing character here is, as compared to the string ABC, is B. So we'll pick up that missing character B and we'll append as prefix for all the permutations of AC. So we'll get BAC and BCA. So now if we see all these strings, if we put all these strings together, we'll get the permutations of ABC. So all these strings are the permutations of ABC. So the answer to the first question is, that is whether it's a recursion problem or not, is yes. So it's a recursion problem, since we are able to use the problem of size n-1, we are able to use the solutions of size n-1 to generate the solution for the problem of size n, and hence it's a recursion problem. So now we have identified that it's a recursion problem. So now we'll move towards the step 2, which is drawing the recursion tree for it for any small input string. Okay. Okay, so this is the recursion tree for the input string ABC. So here in this recursion tree there are 3 levels. So this is level 0, this is level 1 and this is level 2. Now if you see carefully at the level 1, what we are doing is we are fixing the first character and then we are permuting the rest of the string. So if you see here, we are fixing the first character, which is A, and then we are permuting the rest of the string, which is BC. So we get ABC and ACB, or in other words we can say that we are taking all the permutations of BC, which is BC and CB, and we are appending A to it. Now again here we are fixing the first character to B and then we are permuting the rest of the string, which is AC. So we get BAC and BCA. Again, in other words we can say that we are taking all the permutations of AC, which is AC and CA, and appending B to it. Similarly for this string CAB. Okay, so now while implementation we need to track few things. So for that I have used two variables I and j. So this variable I denotes two things. One is the level at which we are currently standing, and another is the index variable, the index that we want to fix, index at which we want to fix the character. So here I equals to 0, that 0 denotes that we are at the level 0 and we want to fix the character at the index 0. Similarly, I equals to 1 denotes that we are at the level 1 in the recursion tree and we want to fix the character at index 1, which is here or here or here. Similarly, for I equals to 2, it denotes that we are at the level 2 in the recursion tree and we want to fix the character at index 2, which is here, 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 here or here. Now apart from the variable I, we have another variable j. So variable j goes from I to the size of string, which is 2. So here I equals to 0, so j will go from 0 to 2 and we make one recursive call for each value of j. So for j equals to 0 we'll make one recursive call, for j equals to 1 we'll make one recursive call, and j equals to 2 we'll make one recursive call. And the value of j denotes the character that we want to use for fixing at the index I. So let us see it with the example. So j equals to 0 denotes that we want to fix the character at index 0, which is a, at the index I. So we are fixing here a, index I equals to 0, so we are fixing at the index 0 the character at j equals to 0, so we are fixing a here. Similarly, j equals to 1, so the character at index 1 is b and we want to fix that character at the index I equals to 0, which is here, so we are fixing b here. Similarly, j equals to 2, so we want to fix the character at index 2 here at this index I equals to 0 here, so we are fixing c here. So we get this three strings at the level 1. Now we are at level 1, which is I equals to 1, and again j will go from I, which is 1, to the size of string, which is 2. Now we'll make again one recursive call for each value of j. So we'll make one recursive call for j equals to 1 and for j equals to 2. Now we want to fix the character at index I, so we want to fix the character at index 1 because I equals to 1, I equals to 1. So now since j equals to 1 here, so and the character at index 1 is b, so we'll fix b here, that is at the index I, we'll fix b here. Now again for this recursive call, j equals to 2 and the character at index 2 here is c, and we want to fix the character at index 1 here, so we'll fix c here. So we'll get these two strings, and now we are at the level 2, which is I equals to 2. Now here the value of I is equals to the size of the string minus 1, and when the value of I is equals to the size of the string minus 1, we say that we have only left with one character to process. And this is the base case, because for the problem that we are given, that is to generate all the permutation of the given string, when we are having just string with just single character, we can say that the permutation of the string with that single character is that string itself. So here in this case, for the string c and string b, the permutation will be that string itself. So we can fix this c and b here and can return. So this is the base case. Okay, so we can do the similar things for BAC and CBA and we'll get this and this. And if we put all of this together, we'll get all the permutations of ABC. Okay, so this was all about the recursion tree. So now we'll write the template function. Okay, so now let us look into how we can write the function template for this problem. So here I have named the function as permutation and its return type is void, because we'll be printing all the permutations for the given input string within this function itself, and will return nothing, and hence the return type is void. Apart from that, this function takes two arguments. One is the string str and another is the index variable I. So this string str is nothing but the current string, which will keep on changing as we'll move along the recursion tree. and another is the index variable I, which is as per our discussion while drawing the recursion tree. Now apart from that, we have another variable j which we used while drawing the recursion tree, but we haven't considered it as the argument for this recursive function here, because this variable j will be used or will be declared within this function here and will be used for making the recursive calls. So basically we'll make one recursive call for each value of j. Okay, so with this we are done with the step 3, which is writing the function template. Now we'll look into how we can write the recursive calls. Okay, so now let us look into how we can write the recursive calls for this problem. So as per our discussion while drawing the recursion tree, we have the variable j which goes from I to size of the string -1. So here I equals to 0, so j will go from 0 to size of the string -1, which is 3 minus 1, which is 2. Similarly here we are at level 1, I equals to 1 here at this level, so j will go from 1 to size of the string -1, which is 2, so 1 and 2, and that is exactly what is conveyed here. So we have this for loop where the variable j iterates from I to size of the string -1. Please note that this is size of the string -1 because of this less than operator here. Now for each value of the j of the variable j, we make one recursive call which is shown here, and in that recursive call we pass the current string str and index variable I plus 1 since we are moving one level deep inside the recursion tree, so we need to increment the index variable I here. Now before making the recursive call, we do some processing here, and after coming out from the recursive call, we do some processing here. So let us first look into this, some processing that we do before making the recursive call. Okay, so while drawing the recursion tree we discussed, right? So the character at the index I here is replaced by the character at index j. So in this case I equals to 0 and j equals to 0, so the character at index I equals to 0, which is a, is replaced by the character at index j equals to 0, which is again a. So a is replaced by a, or in other words a is swapped by a, so we get this string abc. Now similarly for this case, for this recursive call, I is 0 and j is 1, so the character at index I equals to 0 is replaced by character at index j equals to 1. So in other words we are swapping these two characters, so we'll get this string. So we'll swap these two characters here and we'll get this string. Similarly for this case, we'll replace the character at index I equals to 0, which is a, by character at index j equals to 2, which is c. So basically this c will go here and this a will come here, so we'll get this string cba. So by doing this operation we'll move to the level 1 and we'll get all these three strings. Now I equals to 1 at the level 1 and we'll do the same operation here. So I is equals to 1 and j equals to 1 here, so we'll replace this character at index 1, which is at I equals to 1, with the character at index j equals to 1. So we'll swap this character b with itself, so we'll get the string cba. Now for this recursive call, I equals to 1 and j equals to 2, so we'll replace the character at index I equals to 1 with the character at index j equals to 2. So basically we'll swap these two characters and here, so we'll get this string cba. Okay, so that is what is exactly done here. We are using this temporary variable temp to swap the character at index I and the character at index j. So basically this is the swapping operation. So we are doing swapping operation before making the recursive call. Then we make the recursive call, and after coming out from the recursive call we do something here. So let us see what we are doing after coming out from the recursive call. So okay, let us continue with this example itself here. So we swapped these two character b and a here, and we got this string cba. So basically these two characters were swapped here and we got this string. We made further recursive calls down and we came back, and while moving up in the recursion tree, what we did is we swapped these two characters back. So this ab become ba again, so basically this cba becomes cab. So we retrieved our original string. So what we are doing is, while coming back from the recursive call, we are swapping these two characters here. We are swapping these two characters back here. So that is what is exactly conveyed here. So we are swapping the character at the index I and index j back, which is shown here. Okay, so overall what we are doing, we are swapping the character at index I and j. We are making the recursive call by incrementing the index variable I, and then we are swapping those two characters at index I and j back. So that is what is done in this recursive calls. So okay, with this the step 4 is completed, that is writing the recursive calls. Now let us look into the step 5, which is to write the base cases. Okay, so we already saw the base case for this problem while drawing the recursion tree, right? So for this problem, we hit the base case when the value of the index variable I is equals to the size of the string minus 1. So here in this case, size of the string is 3. So 3 minus 1 is 2. So when I equals to 2, we hit the base case. And when we hit the base case, we are left with the string with only the single character within it to process. And the only permutation of the string with single character within it is that string itself. So we leave that string as it is and will return from that recursive call. Now here, before returning from that recursive call, we'll print this entire string ABC, and then we'll return from the recursive calls. Similarly here, when I equals to 2, we are only left with string with single character B left to process. So we'll leave that string as it is and we'll print the entire string ACB, and then we'll return from the recursive call. Similarly for this 4 cases. So this is exactly what is conveyed here when the value of the index variable I equals to size of the string minus 1. We'll print that string and we'll return from that recursive call. Please note that this return is important, otherwise we'll end up making infinite recursive calls. Okay, so with this entire function permutation is complete. We wrote recursive calls, we wrote base case, and now we can test this function. So for that, we'll write the main function and we'll call this function permutation from it with different input strings to check whether it works properly or not. Okay, so with this I'll end this video. Bye.